In this video I'm going to show you an expect script called pushfile, which allows you to copy a file from a local Unix/Linux system to a remote Unix/Linux system. The script and some of the supporting scripts are available on GitHub under my account, so let me just show you where we can find it. So if we go to github.com, in the search box just search for me, Andy Cranston. Well, there is one user called Andy Cranston, that's me. And if we look at my repositories, the repository that we're looking for is pushfile. That's just currently near the top. It might be, by the time you have a look at it, it might be down there somewhere. But if we click on here, so there's the pushfile scripts and a couple of other supporting scripts and C programs. And this whole documentation explains what we need to do. But the first part explains when you might want to use pushfile. It's when every other method that you've tried to transfer the file has failed for some reason or isn't allowed. So you might have tried to do a secure copy, that's been blocked by a firewall, or it might have, or the server might not be running at the other end. FTP might be blocked. You might have even tried a trivial file transfer protocol, TFTP. You might have tried putting the file on a remote web server, then logging into the remote system and seeing if you can then download it from the web server using a tool like curl or wget. All to no avail. The only thing you've got is you have a way to initiate a command line session on the remote system from the local system. So this will probably make a little bit more sense when I actually show you. So I'm going to log into my local system, which is called Software Store. And I'm going to just download the software. So I'm going to clone the repository. Copy that into my buffer. And if we look now, I've got all the software which I need. So I'll quickly install it. These steps are all in the README file, which you can see on the web page. Compile. So I've got it installed. Part of the installation is also to put a shell script called hex to binary on the remote system. So let's log into our remote system. In this case it's called SmartSet. I'll log in as a different user. Now I have to create the script in here. Now on the remote system, I'm not making any assumptions about what I can do on the remote system apart from establish a Unix/Linux command shell and have access to the fairly standard Unix utilities. I'm not assuming that I've got a C compiler on there. I'm not assuming that I've got root access. I'm not assuming that there are any packages that are already installed which will help me. I'm assuming it's a very cut down, minimal Unix system. Probably one of the reasons why I'm having difficulty using other methods to copy the file there. And also, it's been firewalled really well, so the only thing I've really been allowed to do is actually log into it like this. If we just go back to the README file, so we can see the installing. I've done the install, I've installed the scripts on my local system, I've compiled this little program called binary to hex. The next thing I need to do is basically put a shell script onto the remote system. Now there's a whole series of commands here which will allow me to do it, and if I just copy, go to my command shell here and paste, what we've now got is that's basically set up a shell script called hex to binary. Just to show you what it looks like. very simple shell script. We'll come back to that in a minute. Now, on the local system, in this directory, I've got a file called software123.tar.gz. That's the file which I want to transfer because it's a bit of software that we use to upgrade something. So this is the example. If I go onto the remote system, I'll create the directory data for it. Of course, it's empty. And now what we'll do is we'll transfer the file. Now, I can't transfer the file as is because it's in binary format. I need to convert it to a textual representation because the transfer mechanism only really transfers ASCII files, and ASCII files have got a fairly restricted range of characters in them. So that's what this file binary to hex does. So this executable. So if I run the program, feed it that file, and then put the output into h.hex, you'll see why in a minute. If I look at the beginning of that file, I've got a load of hex characters, and it's pretty much like that all the way through. If I look at the end of it, it's all hex characters. The file's about twice the size, a little bit over twice the size. That's simply because for each byte in the binary file is represented by the 2 characters to represent its hex value. And that's the file that I'm going to transfer, and this is where we actually start to use pushfile properly. So I invoke pushfile with the name of the file that I want to transfer, which is h.hex, and immediately it gives me a shell prompt back. So what I do now is I log into my remote system, on the remote prompt I'll change into the directory where I want the file. Now I'm going to type a character with the plus sign, and what that does is that tells the expect script to take back control and do its magic. So just watch what happens now. Here we go. What it's done is it's reconstructed the file on the remote system by just doing lots and lots and lots of echo statements and basically building up the content of the file. This is great stuff. Right, so now if I exit from here, I'm back to my local host of the script, type in another exit, and the expect script is finished. It's done its work. If I now look over here, this file has appeared here. Let's just check. Both files are 18,501 bytes, but let's just run a md5 sum on the local copy, and let's do the same on the remote copy. And I'm pleased to say that they're the same, so I've got good confidence that they're the same. Now I'm still not there yet because that's h.x isn't any use to me. It's in this, just all of these hex bytes which don't really mean anything. So that's where the shell script hex to binary, which I transferred over a little bit earlier, this takes the hex file and produces the binary file. So we go software.1.2.2.3.tar.gz, and that runs away. Now that's a shell script. Not the most efficient. It'll take a little while to run, even on that short size file, because it isn't particularly efficient. But the reason why it's been written as shell script is you've pretty much guaranteed that you'll be able to use that script on any Unix system, because you're not relying on a C compiler being there or any other useful things. It's a very low level. It exists on every Unix system, so you can always expect it to actually be there. Oh, there we go. That's finished now. So now we look at the file. Let's do an MD5 sum on it. Software123.gz. Let's go back here. Let's do the same thing here. Must have made a typing error there. Yeah, there we go. And again, we can see here that we've got the MD5 checksums are actually correct. What we could also do is we've got the file transferred, everything's done its job, we can get on with the real purpose that we wanted to do. We wanted to get this software, this compressed tar file copied over, so let's uncompress it. untar it, take a look, let's create our directory, and there's all our files in there. So it's basically done its job. Now you might think, where will I really need this? Is this a real world application? Surely copying files around between your systems is, is something that's just easy and it's just really a given. Well, it's not, and I'll give you an example. I actually wrote this software back in the last few months of the year 2000. I was working for Cisco at the time on a short-term contract, and worked in a team where we had to support a number of SunSpark workstations which were in remote locations on customer networks, and our access to them was particularly limited in most cases. Most of the customers who had these Spark Station 5s would only allow us a command line access into it. Sometimes we'll be allowed to secure shell into it. More often than not, we'd have to establish a VPN connection, log into what we call a bridgehead server, and then from there we could then establish a link over a serial line, which would then attach the serial port on the back of the Spark Station. Sometimes we had to log into a terminal server, initiate a reverse telnet connection, and get into the box that way. So we had all these weird amount of ways to actually log in, which was great. We could log in, but we couldn't use any file transfer software or any of the conventional network-based file transfer software. So that's why I wrote this script, to allow us to copy software image files from our office in Stockley Park in the UK out to these SunSpark workstations, which are dotted all over the EMEA region. I think we had one of the systems was over in Riyadh. Before we'd written this, if we had to get a software image, we'd have to burn it onto a CD, stick it in the post, send it over to the customer. The customer would then have to liaise with the customer, who would then go and take the CD and go and put it into the Spark Station for us, where we'd mount it and we'll be able to copy the files. That took quite a bit of time. In extreme cases, customers wouldn't even allow us to do that. They would say, if you want to put a CD into your Spark Station, then you better hop on a plane and fly over and do it. And we actually had to do that on one occasion, which was one of the reasons why I was prompted to actually come up with a way around that. At the bottom of the documentation I've got here, there must be a better way. Of course there is. One of the ways is to install ckermit on both the local and remote systems and do the file transfers that way. It's simpler and it's a lot faster. Of course, if you don't have access on the remote system to be able to install packages, and if you've not been given root access, that isn't really a way that you can do it. So again, you're back to using pushfile. But one of the things that we did at Cisco is, once we realised that this was a good way to do things, all of the new systems that we built, we installed Kermit on them before we dispatched them, so we could then do these transfers in the future. So we fixed the problem for ourselves, and existing systems that are out there in the field, when we got a chance, we would use pushfile to copy the ckermit software installer onto the remote system. Then we'd log in and install Kermit remotely. So it was just a nice way to actually get the proper solution out there. So you can think of it as a kind of a bootstrapping process. You can use pushfile to get software onto the remote system that allows you to then do more efficient software, to do more efficient file copy transfers. And you can also, if you've got software like ckermit, not only can you send files out to these remote systems, you could also get files back, which would be quite useful for diagnostics and things like that. Anyway, I'm waffling now. I hope that you see the power of this. It's a simple idea, and uses expect, which is a fantastic tool. As I said, all the documentation is where you need it on this URL. Let's just remind everyone of it. Put it into Notepad. That's the one you want. And as I said, you might just find yourself in a situation where the only way that you can transfer the files over is to use something like this. And if it is, then that's where to get the software. This is the video showing you how to use it. There's an example run on the documentation on the website there as well. So if you find it useful, please drop me an email and let me know. Otherwise, thank you for watching, and I hope you find the script useful.